Hello, everyone. Can everybody hear me? Type in the chat if you can hear what I'm saying. Yes? Cool. Perfect. Hi, I'm Mira from Supernova. Today we're going to be talking about cryptography. Before we go, there's a few people joining, so I'll just talk about how to use this platform if you've never used it before. I think a lot of you have. I recognize a lot of your names, but just in case you don't know how to use this, there is a little, at the bottom of your screen, below where you're looking at me right now, down there is a little person holding their hand up high. It says raise hand, and you can click that at any time throughout, and our moderator, Hannah, will message you and help you with whatever questions you have. You can also post your questions in the chat if you want them, and people can help and will help you out. You can also click on the little person with the head and the shoulders, and it will come up with feedback. So you got like happy, sad, surprised, confused. But it also says stuff like faster and slower. So if I'm going too fast, if you agree with what I'm saying, click on any of those things throughout, and I will keep an eye on it. But it looks like everyone has joined. Oh, we've got one more person joining. I'll just wait 1 second, and then I will get started. Let me present this slide. Share this again. Cool. So today we're going to be talking about cryptography, and what cryptography is basically like secret codes. So when you think of like a spy writing in secret code and giving it to someone else, that's usually they use cryptography to change normal language into secret, unreadable language. And that's what we're going to be talking about today, because even though this is like you might think of like spies or like, I don't know, whatever, it's also something that's used really often on the internet. It's a really important part of computer science. It's used on probably every website we're on, probably even the website we're on right now. And it's really interesting. So we're going to be doing that today, and we're also going to be coding our own program that will let us encode secret messages. So a little bit about cryptography. So when you take some normal words like hi, how are you, and you turn them into a secret code, that is called encoding. And when you take coded words and put them back into readable English, that's called decoding. So encoding and decoding. And those are cryptography. Cryptography is the science behind encoding and decoding messages. So Morse code is a type of cipher, which is basically like a cipher is the way that you translate letters into code. Morse code's not like a very super secret one, because the idea was that everyone knew how to translate Morse code, but you're still translating normal letters into a series of dots and dashes, which is encoding. And then once the person who receives it hears it, they can turn the dots and dashes back into letters, and that's decoding. Oh, I'm not on the right slide. There we go. So the way that you turn letters or coded letters into English, or turn English into coded letters, is using something called a key. So the Morse code key is just what you're looking at right now. It has one different symbol for each letter. So A is dot dash, and B is dash dot dot dot. But different languages use different things. On the internet, often the key is actually just a piece of code that translates it. So it's not even like a direct like sort of thing that you can translate one thing to another. It's just a piece of code that'll take what you write or take your information, translate it into a bunch of nonsense, And then once it's received by the person you're sending it to, like say you're sending an email or say you're sending something to a website, it will decrypt it on that side or decode it. So it's a key. In computer science, we use cryptography all the time because people share all sorts of personal information online. And most importantly, we share passwords. And websites store your passwords on these things called databases, which are just like kind of like a big storage space where they keep all of your data. But they don't keep them in normal text. So they tend to encrypt them or encode them so that if someone hacks into the database, they'll be able to only see coded language and they won't be able to just read all of your information. Now, sometimes you can still get access to a database and figure out the key that they use to put all the information into code. But sometimes you don't even need to hack into databases. Sometimes if you have a weak enough password, they can hack in anyway. These are two websites that I'm going to post later at the very end of the session so that you can try them out yourself. This one's called How Secure is My Password, the one on the left, which just tells you how hard it would be to hack your password. So in the screenshot, you can see it says instantly. I just typed in the word password, which is like one of the most common passwords ever, and it would crack it instantly, but you can type in your password and it will tell you how long it takes. And there's also this website called Have I Been Pwned, which tells you whether or not you've been signed up to a website or a service with your email that has been cracked or hacked and has had data breaches, which means that your information has been shared. It's pretty interesting. I'll share those later so that we can try them at the end of the session, but we want to get to the coding soon, so I'll keep going. So it really, is it like an Enigma machine? Kind of, yes. I'll talk about that in a second. So a really basic cipher that is a lot like the way that encryption is done on a computer is called a Caesar cipher. And a Caesar cipher is called that because it was used by Julius Caesar way back in the Roman times to translate what he was writing into secret code so that people couldn't intercept his messages. And the way that a Caesar cipher works, it's just two alphabets. So you can see that there's two wheels. There's a little wheel and a big wheel on this like right picture. And they both have the alphabet on them from A to Z. The one on the inside represents your normal alphabet, A, B, C, D, E, F, G, and it can move around, it can rotate. And you can move it so that it's underneath different letters on the big wheel. So when you shift it around, you rotate it, you can actually change the letters or what the letters represent. So normally A would be here underneath A because A is A, but say you shifted it over, just like this one, A is actually under W now. So if I was going to spell my name, I would look on this little wheel and find M, because my name is Mira, it starts with an M. And I would look up here on the big wheel and see that it's I now. And then I would look for the letter I, because it's the next letter of my name. Look at the big wheel and see that it's E now. So it can be kind of confusing because it's in a circle. But really, all that this is doing is shifting letters over. So if you can see this picture on the right here, this is being shifted over by a couple letters. So you can see that now, for this one, D represents A, and E represents B, and F represents C. Really all you're doing is moving all the letters over by one. So if you shifted, if the key was 1, so the key is the amount of times that you shift it over, A would become B, C would become D, etc., etc. And then it would loop back around and Z would become A. It's pretty simple. It's a very basic cipher. I'll show you some examples to make sure everybody kind of gets it. Yes, okay, a couple of you figured out your names. But so here's an example. Supernova, where I work, woo, with a key of 1, which is just shifting the alphabet over by one letter, becomes T, V, Q, F, S, O, P, blah, blah. So ABC would become ZAB. Supernova with a key of 13, which is like rotating it halfway around the alphabet because there's 26 letters, would become this. And then if you shifted it 26 times, A would go all the way around and come back to just being normal. So there's only 26 different keys that you have, 1 to 26, that will change your code. And to decode, you do the same thing. So if I had the code TVQFSOPBW, which was just my translating the word supernova with a key of 1, you can decode it by shifting it again, and all you have to do is take 26, which is the number of all the letters, and you take away that key number, which is just 1, and then now you have your new key that will help you decode. So this, if I translate this, TVQFSO, blah, 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 with a key of 25, it'll take me all the way back to supernova because 25 plus 1 equals 26. It's a pretty basic cipher. But we're going to be making this in Python. And so before we start, I'll kind of explain a little bit about Python so we sort of understand what we're going to be doing. But there's different types of data when you code. So you can have things like numbers, you can have things like words, but you can also have things called characters, which are just the individual letters. So each letter of the alphabet is a different character. And there's actually something called an Ascii table, which translates symbols and letters and numbers into series of numbers. You can see all these numbers and nonsense. It's a little bit confusing. We're not going to have to use this to code, but it's sort of like its own form of cryptography. It's just translating, like for example, if I look at the capital letter A over here, this number over here on the first column is 65, so 65 means A. So that's how we're going to be using this table in our code, and I'll explain to you the lines of the code where we're using these Ascii table numbers. But all you need to know really is that A to Z in capital are represented by the numbers 65 to 90. And A to Z in lowercase are represented by the numbers 97 to 122. And I will show you in the code where we use that. But before I do that, I'm going to share with you this website where we will be able to code. And I linked it in the chat, and you can click on that, and I will print it in 1 second. Let me just present that. So if you go to this website, right here, there you go. If we go to the site, yes, we're going to go to Python 3. So this is online GDB, is something called an IDE. It just lets you write code and it will run it for you within your web browser, so you don't have to download anything, you can just use it online. So what you're going to want to do once you click on this application, on this little link I sent, is you want to go to language in the top corner and click on Python 3. It should be the 1, 2, 3, 4, 5, 6th one down. Python 3. And when you open yours, you might have a bunch of text here. See if I can reload it so I can see the text. Yeah, you might have a bunch of text here. You can just get rid of all of this and delete it so that you have a blank canvas. So everybody do that. Find Python 3 in the top left corner, and you can erase all of the extra text there. It's not that important. And I will start going through this code. So this code, what it's going to do is it's going to let you type something in, and it will ask you what key you want to change it into. So 1 to 26, you can pick whatever number you want, and then it will go through all the letters, translate them for you, and then it will print them out. So The first line we're going to type here at the very top is this: def encode text, comma, s. And we're going to write this. I'll leave this up for a second. So def encode text, comma, s in brackets and a little colon right there. Bump, bump. What this is going to be doing is creating something called a function. And what a function does, it's just a big block of code that can be used a bunch of times throughout your program, but you don't have to copy it and paste it a bunch of times. Like, you don't have to write the same code over and over again. You can just later type the word encode into your text, and it will just call that function and run that code without you having to type it a bunch of times. It's pretty handy. So we're just going to make a little encoding function. And once you type this line, you can click enter, and you should notice that you're starting a little bit higher on your next line because we're now inside of this function. So when you're typing stuff that's inside the function, you want it to be this amount of space out. And if you ever find that you're down here, like on the same line as def, you can just go backspace, go back to where this colon is, and click enter, and you should have one tab space out. And now you just want to write the word result equals, oh, just one equals, not two. And then quotation marks. When you type one quotation mark, it should give you two. So what result is going to be the encoded, the secret code version of what you've written. So right now, what this does is it's just setting the word result to mean nothing, and then we're going to add stuff onto it so that it can be your secret code. And then on the next line, I'm going to space it out so you can see it better. You want to write this. It's going to be a little bit longer. It's going to be the word for, then space, I, space, in, range. And then you're going to get a bracket, write the letters L-E-N, like length, but it's just the first three letters. More brackets, T-E-X-T. And at the end of that, a colon, and I will leave that up so that everybody can write that. It's for I in range len text. So what this line does, this is something called a for loop. It's kind of like a function, but a function, when you call it, just runs once, and you can run it as many times as you want, but if you just write the word encode text s, it will just run one time. But what a for loop will do is it will run all of the code that's inside of it a bunch of times until something specific happens. So this piece of code is going to run until it reaches the end of the words you type in. So it's going to look at every single letter. So say I write the word hello, it'll look at H, and then E, and then L, and then L, and then O, and then once it's done, it's going to stop looping. So that's what this line does. And once you're inside of there, you can click enter, and you should be up 2 tab spaces now, because we're inside this loop, but we're also inside this function. And we're going to write the word char, C-H-A-R, equals text, and then a square bracket, and you can find the square brackets, they're next to the P on your keyboard. You don't have to press shift, it's just there. And when you type 1, you should have 2. And I write I in there, so char equals text I. So char is going to be something called an array, and it's going to have all the letters in it. All the letters from what you type in. So I'll let people do that. So far, all we have is this loop that's like, okay, I'm going to take everything that you write in, and I'm going to look at every letter, and then I'm going to stop. And then we will add some more to our code. So our next line, we're going to do something called an if statement. And what an if statement is it's a piece of code and it has a specific thing that needs to be met for it to run. So kind of like how the for loop will stop when it reaches the end of the letters that you type in. This has a specific thing that will make it start running. So we're going to write the word if, grab some brackets. We're going to write char. It's like up here, char, dot, is, which is just is, upper. So is upper, all one word, or I supper. And you're going to put another set of brackets here, and then at the end of that line, another colon. So this is just going to see if you typed any uppercase characters. So is upper just means like, is this an uppercase letter? Or is it a lowercase letter? Because the lowercase letters and uppercase letters on the Ascii table are represented by different numbers. So it needs to know whether or not it's an uppercase or a lowercase letter. Code text for range, yes. And then under this is going to be a long line, so I'm going to type it and then I'm going to post it in the chat, or one of the moderators will. This is going to be result equals, result plus equals, CHR, 2 brackets, word, char, plus S, take away 65, percentage. Oh geez, where's my percentage? 26 plus 65. And I did this really fast because I'm just going to post it because it's a very long line. Copy this, bam, and paste this. So this is our next line, and I'm going to explain this. So we made result up here. This is going to be our output. This is going to be the secret code. But this loop is going through each letter of what we typed in. So if I said hello, it's starting with H. So it's going to go here, say I typed capital H, and it'll go into this if loop. And what it does is this piece of code translates it, it shifts it over from the letter that it's at, and then it uses S, which is going to be our key. We'll set that up later. And says, okay, so say H is this number letter of the alphabet, but we're going to move it over by 2, so it's going to be J, for example. So that's what this does. It'll turn it from H to J. And then this part, result plus equals, is just going to add this to the end of this line. So far there's nothing in it, but now when it adds this, it'll just be the letter J. And then the loop will run again, look at E, and then when it translates that, it'll add it to the end of it. So it'll be J, whatever. It'll be JG, because if my key is 2. So that's what that does. So you can just copy that. I put it in the chat. And Hannah just posted all of the text that I've done so far. It's a little bit confusing. It'll get easier from here because we can copy paste. So you want to click enter again, and you can click backspace because we now want to be back on this level. So we're 2 spaces up. We're on the same level as this if statement because we're done with this line. Super done. So we're going to write ELIF, which stands for else if. So we've got if this happens, do this. And now we're going to do else if else if this happens, do this. So we've got elif. This is going to be a lot easier. Put some brackets in. You just want char equals equals. That's 2 equal signs. Very important. And then bracket, or not bracket, quotation mark. God, I'm confused. And just, you want to put a space in there. So up here we have quotation marks with no space. You want just like a space in here. And then you want to put a little colon there. So what this will do is it says, okay, if the character I'm on is a space, because this is looking at letters, but if you're doing a space, you don't want to translate the space, because even spaces have their own numerical values. So if you don't put this part in, it'll just try to like translate the space to like a different symbol, and it'll all get kind of confused. So if you write like, hi, I'm Mira, you want all the spaces to stay the same. They don't need to be translated. It's just a space. So elif char equals space. Click enter. Make sure you're 3 tabs up on the same line as this. And you want to write result, or you can actually, here, just copy this part. Just the result plus equals. And you can say quotation mark, space, quotation mark. So you're just going to add, if it finds a space, it adds a space to the output. If you write hi, space, I'm, it's going to be translated code, space, translated code. So that's our next line. Give everybody a second for that one. And one more else statement. And you got to make sure, I'm just going to emphasize this, that the ends of your for loop, your if statements all have a colon. Otherwise, your code might not work. You need these so that it knows, like, okay, this is inside of this. That's what those colons are for. It says this is going to be inside of this loop, or it's going to be inside of this if statement. I'm going to click enter. So for your last one, it's going to be the easiest one because we just have to copy paste. So you're going to write the word else, just else, and a colon. Click enter, and then you can copy this entire line, this result plus equals blah, blah, blah. And you can paste it. And the only thing you have to change with this is the numbers 65. So there's 2 65s in this line, s minus 65, and you've got this plus 65 over here. And all you need to do is change those so that they say 97. Once again, just copy this line. For me, it's line 8, the result plus equals char, blah, 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 blah. Paste it here, and then just change the 65s to 97s. The 26 can stay the same. All the other things can stay the same. Just change 65 to 97. And then we're done with the hard lines. So I'll give you some time to do that. Delete this line. Bonk, bonk. Yes, so next thing we're going to do, the last line in our function is going to be this. So when I'm at the end of this line, I'm going to click enter. And I want to go back so that I'm on the same line as this 4 all the way back here. So it should be tabbed up by 1. When you're up here, you're like up by 3. You can just click backspace and it'll take you back here. If you backspace too far, you can always just do it again. You just want to be the same level as 4. And what you want to do, type the word return and then result. Result. Yeah. So that'll be the end of our function. So what this does, it will just return this, which will be our outputted code, our secret encoded message. And then I can backspace, so I'm all the way at the very first line, just like on def. I'm all the way over to the left. And there's a couple more lines to write. There's 3 more lines actually. Because up here we have def encode, which is the name of our function, and then we have the words text and s. And these are 2 things called variables. And text is the stuff that you type in. And S is our key. It could just be K, but it's S for this one, I guess. So we haven't even defined those yet. So that's what we have to do next. So I'm going to write the word text equals input. And then I'm going to do some brackets. So what input is is the things that you type into the program. So whatever you do, that's what text is going to be. And then inside these brackets, behind input, you want to put some quotation marks. And you want to write, I'm going to say, what do you want to encode? Question mark. You can type something like, oh, what will your secret message be? Or something like that. This is just, it's just going to ask you this, and then you can type in your text that will be translated. So mine's going to say, what do you want to encode? And my next line is going to be similar. It's going to say S equals int in brackets. And then you can even copy this if you want to. This part that says input, blah, blah, blah. And you can paste that in because it's a little bit faster. So it's int input. But I'm going to change this from what do you want to encode to what is the key. Oh, geez, I can't spell. So this will take in a number, and that will represent the key or the amount that you're going to shift the alphabet over in order to turn your normal text into secret text. So I'll let these two lines done. Oh, my computer. What is happening? I'll let people put those in. And our last line is simple. We're just going to write print because we're going to want to print out our coded text. Get some brackets going, and then inside the brackets, type quotation marks. And then you want to write, I'm going to say coded message. And at the end of these two quotation marks, I'm going to do a little plus sign. Just say coded message and then plus outside of the brackets, or outside of the, coded message in quotation marks, and then I write a plus outside of the quotation marks. And then I'm going to write this. I'm going to write encode text S, and you can just copy this from up here. Copy, paste. So this will call this function, and it will run all of this. So you're going to write, what do you want to encode? You're going to write Mira. And then you're going to write, what's the key? And I'll write 2. And then it will say, this is your coded message. And it will run this, and it will print out, it will return your secret coded version of what you typed. And that is the entire program. So I'll give everybody a couple seconds to do it, and I'll show you how to run the program. A bunch of the text has been posted in the chat, so if you're having trouble following along, you can just copy paste from there. And then I will show you how it's done. Print coded message, yeah. So this should be your code. And why does the code have different colors in it? Usually, it's actually not important whether or not your code has colors in it. What the colors are for programmers so that they can tell the difference between the different things that they're doing. So I know that my code is in quotation marks because it's green, so I can tell that it's inside. And if I'm trying to type something and I want it to be in quotation marks, but it's not turning green, I know that I've got a problem because it should be green. Usually the orange ones are like I don't know how to describe them, but they're like functions, I guess, so that you can tell the difference between things you're typing and like specific important things that the computer understands. It's mostly just you can so that you know what you're doing, basically. And you can usually change the colors. A lot of IDEs or like things that you code in let you change the colors so that you can like put them as colors that you want them to be. But I don't think that this one lets you do that. But yeah. Anyway, if you've put this code in, it should look like this. Most of it's posted in the chat, so if you miss something, it should be there, but I'll make it big again. I'm just gonna drag up my little thing down here that says input on it. You might notice that we've put input into the chat. Input just means the things that you type in. So what this lets you do is it lets you run your program and type stuff into it. So in order to make this input work, you want to click run. It's this green button at the top of your screen next to debug and all this stuff. All you want to do is run, and it should start running. Now you might have an error, so I'm going to delete a piece of my code just so it shows an error. It wants me to stop running. So you might have an error if you have a problem with your file. If that is the case, you can just copy and paste it into the chat and we can help you debug it. But mine did not have errors in it, so I'm going to run it. And it asks me, what do you want to encode? And I'm going to write my name, Mira. And it says, what is the key? And I'm going to say 1 so that it just changes it by 1 letter. So N becomes N and so forth. And then it has coded it. So here's the coded message, NJSB. That's my name, shifted over by 1. That's a secret version of it. So everybody try to do that. Do it with your name, do it with something, and you can post it in the chat. Actually, if someone wants to post their coded message in the chat and give me the key, I can try to decode it for you if you want to, because I'll show you how to decode. All you have to do, I said, oh, what do you want to encode, Mira? What's the key you want, right? And it's given me this coded message. I can copy it, my secret message. I can run my program again. It'll say, what do you want to encode? And I can paste in that secret code. What is the key? I know that the key was 1. So in order to decode it, I wanted to take 26, take away 1, which is just 25. Bam. And it turned it back to Mira. Easy peasy. Ooh, NJEW, the key is 9. Okay, I'll do it again. So NJEW, the key is 9. So 26 take away 9 is, I can't do math, 17, I think. Yep, 17, I can do math. So I'll shift it to 20 or 17, and bam, Evan. Nice, easy peasy. But I can do that with anything. So this can be really fun. If you know somebody else who has the same program as you, you can say, here's the secret message. Send it to them with the key, and they will be able to translate it back, and no one will ever know. Oh, I'll try it. Okay, key 3, send on over your coded message, and I will decode it for you. But yeah, so all this is doing is shifting the letters over by a certain number. It's a pretty simple program. I mean, it's a little bit confusing when you look at it, but it's actually just a few lines of code, and it does some pretty cool stuff. This code could probably even be modified so that you could encode it or decode it. Like it could be like, do you want to encode or decode? Else if ELIF char equals space syntax error, invalid syntax. Claudia, you might not be, you have to make sure that I got the same error as Claudia. syntax error, invalid syntax. Is it always for the elif line? Char equals space. No idea. Let's see. Make sure you're on Python 3. I guess it's the only one that's there. You have a syntax error for line elif. You gotta, how about, make sure that elif is tabbed out 2 spaces. So it's like, you got, this is the no tab, this is 1, and this is 2. So it needs to be spaced out correctly. That could be the problem, that it isn't like spaced out. And you can, if you, oh, it won't let me edit, give me a second. You can just use the tab button to put it up to its correct space. But yeah, elif needs to be tabbed up 2 spaces. That could be your problem. Okay, wait. Okay, I'll do Jade's. She sent me one. Jade Law Jones. Okay. So this is this. And the key is 3. So let me try this one. I want to encode this. The key is 3, so 26 take away 3, it's 23. I love this. Aw, cool. I like it too. Ooh, this is the code, and the key is 10. Okay, I'll try that out. Evan. Let me run it. And it's 10, so 26 take away 10 is 16. Online debugger. Nice. That is the name. Getting the same error as Jesse. Main pi, line else, invalid syntax. So you also have to make sure that could also be an issue with spacing. So you have to make sure that everything is spaced out on the same amount of lines. So this line, no spacing. This line has 1 tab. Both of these lines are tabbed up by 1. All of these lines, char, if, and else, all have 2 tabs in front of them. And these ones, results, all have 3 tabs. So it has to be exactly like that. The way that Python works is it only understands what is inside of what, like what code is being run by other pieces of code if they're tabbed out correctly. So it only knows that this result line is inside of if because it has been spaced up by 1 space. In other languages, you actually don't need to space things up. They have different things. Usually lines will end with like a comma or like a semicolon or something. But Python's easy because it just wants you to have everything spaced out. So if you're having problems that say something like syntax error, it could be because your spacing is incorrect. And it has to be a full tab, so you can use the tab button, and that might help you. Can I go to line 18? I sure can. Right here. Oh, or this is my last line, but okay. Key 12, code a message. Fancy. Well, let me run. I want to encode this, and the key was what? 12? Cool. So 26 take away 12 is 16 take away 2, which is 14. I'm still not good at mental math. Is that right? 14 and 12 is 26? Oh no. You have 18 lines. That's okay. I have 17 lines. You might have just, I just deleted a line, so it's okay. As long as you have all the things that I've typed. Mine's weird. It says the coded message is only 1 letter. It might be because you have to make sure that after result on these 3 lines, let's say result, for me it's line 8, 10, and 12, that they have to say plus equals. So the plus symbol and the equal symbol next to each other. So what this does is it will add the translated letter to the end. So plus equals is just basically like a fancy way to say plus. You're just adding a letter. So they all have to say plus equals, and plus equals will add it to the end of the line. And Lucas, you're still getting a syntax error, invalid syntax. Can you send the full error message? Just like copy and paste it in. It is plus equals, says Elise. It says the code of message is only one letter, and it says plus equals. Here. What I'll do is I'll copy this in. Whole thing. You can try copy and pasting all of the code in, and it might be able to work better for you. If I could see your code, it would be a lot easier for me to help you debug it, but I can't be with all of you right now. So if you're having trouble and it's not compiling, you can always copy it. I just pasted all of the code in the chat, and it should be spaced out correctly if you copy and paste it into your program. Yes, it is. Except I don't need this. Yeah, it also, yeah, if you copy paste from the chat, it imports the line that says like copy and paste from the chat or something, and you don't need to, you can get rid of that line. It should just be lines 1 to 18 like this. But yeah. So this Caesar cipher is kind of similar to how computer science encryption is. And it's a lot harder than something like Morse code. So what Morse code does is it's got one letter for each, or one for each letter. So you know A is always dash dot dot or whatever. But this can be changed. There's 26 different variations. It would be like if Morse code had like a bunch of different symbols for A and you could just choose one. That's kind of what this is like. So it's a lot harder to crack, because if you were looking at Morse code and you figured out what each sequence of dots and dashes represents, you could really easily oh my god, my brain just stopped working for a second. You can really easily figure out every single person's Morse code messages. But with a Caesar cipher, it can change it up. Maybe you figure out the key at one point, and then you find another message and you try translating it, it's still nonsense, and you're like, whoa, they changed their key. But it's still pretty simple because there is only 26 different keys, and if you figure out how to make your own program or make your own physical Caesar cipher, you could really easily just crack any code. It doesn't take that long to go through each 26 versions of the alphabet and figure out cryptography at Supernova. But yeah, so it's a lot more like the way that we do it online, because online usually keys are pieces of code, but they're always different. So if someone cracks it one time, it'll be a lot harder to crack another time. Sort of like that's kind of how the Enigma machine worked. There were all sorts of different rotating circles with inside of it that would change the key that you turn things into code with. But yeah, and the way that it works is it encodes stuff when you send it, because when you send things online, it doesn't immediately go, like if you sent an email, it wouldn't immediately go to the person who you're sending it to. There is an amount of time, and there is like a physical space that it translates, that's not the word, transfers over, that it travels over to go to another person's computer, and that can be intercepted. So if websites encode their information that they're sending around so that nobody can intercept them along the way. That's why if you see websites that say like HTTPS, that means that you know that all the information that's being sent on the internet from your computer to whoever, to other people's computers, to their databases or whatever, are being encrypted so that they can't be interfered with by random people on the internet, random hackers who want to get your passwords. But some websites that don't have HTTPS don't encrypt everything that's on their websites, so it can be a little bit less safe. So if you're going to put a bunch of secret information on a website, you should probably make sure that you're on an HTTPS website. And in Chrome, I can see it right now. The website you're on, there's like a little lock or a little unlock, and it'll tell you whether or not you're on an encrypted site. Oh, I'll do this one. This message is Urmzu and the key is 17. But yeah, That's about all I've got for you today. Been here for way longer than I thought we were. But go ahead, play around with it. If you're still having trouble, I posted it in the chat. And I hope that you learned something about cryptography. If you have any more questions, I am cool with answering them. Let me just decode this. Nice. Nice, nice. But yeah, that's all. Does anybody have any questions? If not, you can feel free to head out. At the beginning of this thing, you said there was websites or passwords. Oh yes. Oh my gosh, I almost forgot to paste those. Let me go grab them. And you can try them out. Let me see. Where am I? Where are my links? Here they are. Bam and bam. Yeah, you can go on. Oh, I have to sneeze. No. Okay, you can go on how secure is my password. You can type in a password. Maybe not type your own, but you can type in something like it, and it will tell you how long it will take to crack it. And you can go on have I been pwned, and it will tell you whether or not your email has been signed up to any accounts that have been hacked. But yeah, thanks everybody. Peace out. And Claudia, yours will be the last one I do. Like this. Bam. And the code 22, so 26 take away 22 is 4. Claudia, nice. Nice, nice. But yeah, thank you everyone. I hope you have a good day. I hope you learned some cool stuff. Send some secret messages. And goodbye. Have a good week.